Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Decarboxylation, loss of CO2 on heating, occurs readily for specific classes of carboxylic acids. The two classical cases are 1. Beta-keto acids, where the carbonyl group is beta 2 carbons away, i.e., at the beta position, to the carboxyl group, allowing a 6-membered cyclic transition state, and 2. Malonic acid derivatives, 1. 3 diacids, which also decarboxylate via a similar cyclic mechanism. Step-by-step analysis of each compound. Compound 1, cyclohexane 1,4-dione. This is a diketone with no carboxylic acid group. No CU means no decarboxylation possible. Does not undergo decarboxylation. Compound 2, methyl 1-oxocyclohexane 2-carboxylate, a beta-keto ester. This compound has an ester group, CO2CH3, not a free carboxylic acid. Beta-keto esters can undergo hydrolysis followed by decarboxylation, but on simple heating alone, without hydrolysis, a free acid is required for the classic decarboxylation mechanism. The ester cannot form the required cyclic transition state for direct decarboxylation. Does not readily undergo direct decarboxylation on heating. Compound 3, 2-oxocyclohexane 1-carboxylic acid. This is a beta-keto acid. The carboxylic acid, CO2H, is directly attached to the ring carbon, that is alpha to the ring ketone, C is equal to O. This means the carboxyl group is beta to the carbonyl, or equivalently, the carbonyl is beta to the CU, fulfilling the beta-keto acid criterion. Beta-keto acids readily undergo decarboxylation on heating via a 6-membered cyclic transition state involving the beta-carbonyl oxygen, losing CO2 to give cyclohexanone. Undergoes decarboxylation. Compound 4, cyclohexane 1,2-dicarboxylic acid. This is an ortho 1,2-diacid, phthalic acid analog on cyclohexane. Malonic acid 1,3-diacid, decarboxylates, but a 1,2-diacid, succinic acid analog, does not readily decarboxylate. Instead it tends to form a cyclic anhydride on heating. This is not a beta-keto acid or a malonic type diacid. Does not undergo decarboxylation. Why other options fail? Option A, 2 and 3. Compound 2 is a beta-keto ester, not a beta-keto acid, so it does not directly decarboxylate under simple heating. Option B, 3 and 4. Compound 4 is a 1,2-diacid, not a 1,3-diacid, malonic type, so it does not decarboxylate. Option D, 1 and 4. Neither compound 1 nor compound 4 has the structural requirement for decarboxylation. Only compound 3, a beta-keto acid, meets the structural requirement for facile thermal decarboxylation. Therefore, the correct answer is C. Therefore, the correct answer is option C.